Question 6. The mixture of gases used in the photographer's flash tube is A. Argon and Krypton, B. Krypton and Xenon, C. Helium and Argon, and finally D. Argon and Xenon. So one can immediately tell that these are all noble gases. Then we have Argon, Helium, Xenon, and finally Krypton. However, we're going to use the method of elimination now to get the correct option here. The moment you hear argon, what should come to mind in terms of its application that it uses should be welding and cutting of metals. And whenever you hear helium, that's the uses of helium, what should come to mind should be balloons. So now with this, we are going to apply the elimination to the options. So we have argon here, and since we are focusing on photographer's flash tube and not welding and cutting, so immediately we delete argon. And since helium deals with what? Balloons, so this is out of it. So the only option that is left is option B, and that is the correct option. So moving on, we have question 7 and 8. Use the section of the periodic table to answer question 7 and 8. Question 7 says, which of the letters indicate an alkali metal and a noble gas respectively? So we know that a noble gas by default, they are all what? They are always group 8 elements. So it means we just have to find which letter happens to fall in what? Group 8. So before doing that, let's number the periodic table. So group 1, 2, 3, 4, 5, 6, 7, 8. So the only element or letter rather in group 8 is L. So it means automatically not A, not B. So we have a tie between C and D. So the next criteria is alkali metal. And alkali metal is the other name for what? Group 1 elements. So now again, we just have to look for which letter falls in group 1. So luckily, we have option G, and that means option D would be the correct option. Question 8 says, which letter represents a non-metal that is solid at room temperature? So first off, what exactly is D? T. Letter T represents sulfur. Letter R represents aluminium. Letter J represents, Letter J represents oxygen. And finally, letter X represents beryllium. So a non-metal, sulfur is a non-metal, aluminium is not a non-metal, oxygen is a non-metal, beryllium is a non-metal. So we have a tie between sulfur and oxygen. The other criteria is it must be solid. So we've really not heard of solid oxygen. So oxygen has always been gaseous. So it means oxygen is out of the race. So the correct option will be option A, sulfur. That's letter T. Moving on, we have question 9. An acid anhydride An acid anhydride is an oxide of a non-metal, A, which will not dissolve in water, B, whose solution in water has a pH greater than 7, C, whose solution in water has a pH less than 7, and D, whose solution in water has a pH of 7. So we have a bunch of words here: acid, anhydride, oxide, non-metal. Let's look at what they mean. So we have anhydride. So what anhydride pretty much refers to is anything in which water has been, let's be specific now, a compound in which water has been removed from, is referred to as anhydride. So let's imagine we have calcium hydroxide, Ca bracket OH2. If we were to subtract the water molecule, what we have left is CaO, because 2 hydrogen have been cancelled, 1 oxygen now. So calcium oxide here is an anhydride of CaOH2. So now we're good with what anhydride means. The next is acid anhydride. So in the case of anhydride, we have to use a random compound. However, since we have an acid anhydride now, we have to use a what? An acid. So now we have HCl, H2SO4, H2CO3 and all. We can't obviously use HCl now because it doesn't have an oxygen atom to begin with. So let's go with H2SO4. So we have H2SO4 minus H2 would give us SO3. So yeah, this now is an acid anhydride because it's an acid. H2SO4, that water was what subtracted from, and the product is what the acid anhydride. So now let's look at option A, which will not dissolve in water. We can't say for certain if sulfur trioxide now will dissolve in water or not. So let's put a question mark there. We are not entirely sure. So if perhaps we are able to prove that the other options are wrong, then that would be the correct option. And if we are able to get a correct option, then that would mean this is wrong. So option B, whose solution in water has a pH greater than 7. So it means what it's pretty much saying is acid plus anhydride. Sorry, this should be water since solution was mentioned. So water plus anhydride should have a pH greater than 7, and we know that solutions with pH greater than 7 are what? Bases or alkali. And this water, so we have H2O, acid anhydride is SO3. What we have is H2SO4. So H2SO4 is not a base or an alkali, so this option is wrong. Whose solution in water has a pH less than 7? Yes, acid has a pH less than 7. So automatically this makes option C the correct option. So moving on, question 10. Yeah. What is the percentage by mass of oxygen in this compound? We have option A 14.29%, option B 25.39%, option C 50.79%, and finally option D 59.25%. So percentage by mass. Percentage by mass is giving us mass of what we are interested in this case oxygen. So mass of oxygen divided by total mass, that's the mass of the compound, this, multiplied by 100. So mass of oxygen. First off, how many oxygen do we have there? We have 4 times 2, that's already 12 plus 2 times 1. So 12 plus 2, that's 14 oxygen. And we've already been given the mass of a single oxygen. So 14 times 16 should give us 224. So now we need the total mass of the compound. So first off, let's list the elements present in the compound. We have aluminium, sulfur, oxygen, and hydrogen. So we have how many aluminium? 2 aluminium present. And since 1 aluminium has a mass of 27, so that's 2 times 27. That should give us 54. Sulfur, we have 3 sulfur present here. So 32, that should give us 96. So 3 times 32, 96. Oxygen, we have, we've done that, 14 times 16 plus 224. Now, majority of the time, students are often make the mistake of ignoring oxygen whenever they are calculating the total mass. You don't have to ignore it in the sense that oxygen is still part of the compound, so it doesn't make sense to eliminate it just because you've already calculated it individually. So we have how many hydrogen? We have 4 hydrogen present. So 4 times 1 equals 4. So if we were to add everything here, we are pretty much going to have 378. Add everything here. So 378. So we can proceed with this. Percentage by mass equals 224 divided by 378 multiplied by 100. Now if we were to solve this, we should be getting 59.25% or something very close. That means option D is the correct option, and that is our answer.